ಹಾಯ್ ಹಲೋ ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಕ್ರಿಯೇಟಿವ್ ಥಿಂಗ್ಸ್ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸ್ವಾಗತ. ಇವತ್ತಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಕಂಟಿನ್ಯೂಡ್ ಪಾರ್ಟ್ ಆಫ್ ರಿಲೇಷನ್ಸ್ ಅಂಡ್ ಫಂಕ್ಷನ್ಸ್ ಆಫ್ ಸಾಲ್ವಿಂಗ್ KCET ಕ್ವೆಶನ್ಸ್ ಫ್ರಮ್ ಪ್ರೀವಿಯಸ್ ಇಯರ್ಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಆಲ್ರೆಡಿ ನಾನು ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಕ್ವೆಶನ್ಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡಿ ವಿಡಿಯೋಸ್ ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಇನ್ನು ಯಾರ್ಯಾರು ವಿಡಿಯೋಸ್ ನೋಡಿರೋ ಜಸ್ಟ್ ಗೋ ಥ್ರೂ ದೋಸ್ ವಿಡಿಯೋಸ್. So today I'll be discussing few questions of PYQs and we'll be completing with this chapter relations and functions. So in coming classes I'll be discussing with next chapters. So you can make a note of all these formulas and already ಹೇಳ್ದಂಗೆ if ಎಲ್ಲ formulas ನ ಒಂದ್ ಕಡೆ ಬರ್ದಿಟ್ಕೊಳ್ಳಿ, ಒಂದು notes ತರ short notes ತರ ಮಾಡಿ ಇಟ್ಕೊಳ್ಳಿ so that you can make use of these formulas whenever required in the question. So now we'll move on to the next question which we have stopped in the last video. Okay, so we'll start with 17th question from the year 2016. So now what is given in the question? The set A has 4 elements and the set B has 5 elements. Then the number of injective mappings that can be defined from A to B. Basically injective mapping nothing but 1-1 mapping. So let us first record the data given here for 17th question. The set A has 4 elements. That means number of elements in set A, let me take the letter M, is equal to 4. And set B has 5 elements. That is number of elements in set B is equal to n, which is equal to 5. So as you can see here, the value of n is greater than m. If that is the case, in the beginning I have given you one important formula to find out how many injective mappings can be defined from A to B. That is n p m. Okay, so according to this it is 5p4. So basically it is 5p4 where you make use of permutation formula 5 factorial divided by 5 minus 4 factorial, so which is equal to 5 factorial. So answer for 5 factorial will be 120. So which option is the right option? Option D is the correct answer. So what if n is less than m? What do you do if n is less than m? If n is less than m for injective mapping, the answer will be 0. Okay. So here in this case, n is greater than m. So n is greater than or equal to m, then we can apply this formula npm. Suppose if n is less than m, what do? You directly write the answer for injective mappings as 0. Okay. So next, further moving on to the next question. Next question, 18th question from the year 2015. What is been asked here? They have given a function f from R to R, that is domain and codomain to be real numbers, defined by f of x is equal to 1 by x. So it's very important you all observe the domain and codomain given here. They have given it as real numbers, which includes natural numbers, whole numbers, integers, rational numbers and irrational numbers along with 0, isn't it? So the function given as 1 by x, if I put x is equal to 0, so what happens to the given function? The function will be not defined. So since the function itself is not defined, you cannot even tell it is 1, 1 and on 2, since the domain and codomain given is real numbers to real numbers. So now the answer for this very easy option B, which is not defined. Suppose if they give you the domain and codomain as r minus 0 to r minus 0, so then you could have gone with checking of 1, 1 and on 2. But here since it is including 0, you tell that the function is not defined. So coming on to the next question, 19th question. 19th question, just have a basic idea because this question is not included in your syllabus. So basically what is being given in 19th question, they're telling that A module direct sum B is equal to A square plus B square. Just they're asking you to find out the value for 2 direct sum 3, direct sum 4. Okay, so now apply this definition given here for 2 direct sum 3. It will be 2 square plus 3 square and this remains as it is. Now 2 square plus 3 square will give you 4 plus 9, which is 13, direct sum 4. Now again apply the definition for this. It will be 13 square plus 4 square, which is 169 plus 16, which gives you 185. So which is the right option? Option B is the correct one. So moving on to the next question, an interesting question basically. So next question, let S be the set of all real numbers. A relation R has been defined on S by A related to by B as modulus of A minus B less than or equal to 1. Then R is, you have to find out whether it is reflexive, symmetric and transitive using this condition. It's very simple. As you could see here, 20th. First we'll go with reflexive. The condition given is mod A minus B less than or equal to 1. So for reflexive, what we will do, we will consider mod A minus A, which is equal to 0. So now since obviously 0 is less than or equal to, you tell A comma A belongs to R. Correct? A comma A belongs to R. Since you choose any number, it will always be less than, it will be less than or equal to 1. So this implies that R is reflexive. So now when you move on to symmetric, you just write mod A minus B less than or equal to 1. So what does this mean? For what, why are you writing this? You are writing this because you are taking A comma B belongs to R. So now what you need to show? You need to show that B comma A belongs to R in order to satisfy symmetric condition. So now you have modulus of A minus B less than or equal to 1. Now what we will do? We will take out negative sign common. You get B minus A modulus of B minus A less than or equal to 1. So this is nothing but modulus of B minus A less than or equal to 1. What is the reason for this? Modulus of x is equal to modulus of minus x. So since modulus of B minus A less than or equal to 1, this implies B comma A belongs to R. So it is satisfying the definition of symmetric condition also. So now the interesting part is about transitive. So what do you think? It satisfies reflexive symmetric, so you will guess that it will satisfy even transitive, but no, there is an example which can be given to this, which doesn't satisfy transitive condition. So basically what does transitive condition tells? If A comma B belongs to R and B comma C belongs to R, you need to show that A comma C belongs to R. Correct? This implies that A comma C belongs to R. So now let us consider the example A is equal to 1, B is equal to 1.8 and C is equal to 2.6. So if A comma B belongs to R, what is the condition? Modulus of 1 minus 1.8, which is equal to 0.8, which is less than or equal to 1. Yes, correct. If B comma C belongs to R, modulus of 1.8 minus 2.6, which is equal to 0.8 again, is less than or equal to 1. This is also correct. Now you need to check for A comma C. So A comma C means 1 minus 2.6, modulus of 1 minus 2.6. So what is the answer you get? You get 1.6, which is not less than or equal to 1. So for the third condition, this has been not satisfied. So what do you conclude from this? We conclude that it is not transitive. Transitive condition is not satisfied. So which is the right option? It is symmetric, reflexive, but not transitive. That is option C is the right option. So moving on to the next question. For any two real numbers, an operation defined by A star B is equal to 1 plus AB is satisfying which of these condition? Is it commutative, associative? It is neither commutative or associative. Let us check with this. So 21st question. So commutative is A star B must be equal to B star A. So let us see whether it is equal or not. So A star B is 1 plus AB. I can write this as 1 plus BA. Okay, so this is nothing but B star A. So therefore it is commutative. So next moving on to associative, A star B star C should be equal to, this should be equal to A star B star C. Okay, so first let us check whether it is equal or not. We'll consider the LHS part. If it is A star B, it is 1 plus AB star C. So this is equal to. So now I'm just considering the LHS part. Okay, this complete thing acts as A. So now you have A star C. So this will be 1 plus AB, which is A into B. So this is like A and this is like B. 1 plus AB. So now when you multiply C here, 1 plus C plus ABC. Okay, equation 1. So we'll consider RHS. This is equal to A star. For B star C, you apply the definition 1 plus BC. So this is equal to 1 plus A into B. A into 1 plus BC. So this is equal to 1 plus, multiply A inside, A plus ABC. So this is equation 2. Now compare equation 1 and 2. It is 1 plus C plus ABC. But here it is 1 plus A plus ABC. What do you conclude from this? 1 and 2 are not equal. That is, A star B star C is not equal to A star B star C. So this means it is not associative but commutative, which is the right option. Option B, commutative but not associative. So now moving on to the next question, which is from your NCERT textbook exercise question, which has been directly asked here for CET. So the question given is a function f from n to n defined by f of n is equal to, there is two condition, n plus 1 by 2 if n is odd and n by 2 if n is even. N plus 1 by 2 for odd, n is odd, and n by 2 if n is even, isn't it? So now we'll first check for 1, 1. So let me consider n is equal to 1. Since n is equal to 1 is an odd number, we'll make use of this condition. So we'll get 1 plus 1 by 2, which is equal to 2 by 2, which is equal to 1. Here, since we'll take n is equal to even number, which is 2, I'll get 2 by 2, which is equal to 1. So now if you look at these two, you're getting f of 1 is equal to f of 2 is equal to 1. So both of them, you're getting the answer as 1. But 1 is not equal to 2, that is this and this value is not equal to 2. So basically what is it? F of x1 is equal to f of x2, correct? F of x1 is equal to f of x2. But x1 is not equal to x2. So what does this imply? If this is the condition, what does it imply? It implies that f is not 1, 1. So you can eliminate the option. Option D is eliminated, option B is eliminated. So now comes the doubt between A and C. So in order to confirm with this, you have to check with onto. Obviously, the function will be onto. So for onto, you will take y is equal to n plus 1 by 2. 2y is equal to n plus 1. So n is equal to 2y minus 1. So now f of 2y minus 1 is equal to 2y minus 1 plus 1 divided by 2, which is equal to y. And then for second case, y is equal to n by 2. So n is equal to 2y. So now f of 2y is equal to 2y divided by 2. So which is equal to y. So from this you conclude that f is onto. So for every element in codomain, there will be an element in domain such that the element in codomain will act as an image for it. So there will be no element which is left out. Okay, so this implies that the function given f of n is onto. So now based on this, the answer is it is onto but not 1, 1. Okay, so with this, we have completed the PYQs from 2014 to 2025 for the chapter relations and functions. So next classes we'll be doing it with other chapters for inverse trigonometric functions, matrices and determinants, and then coming chapters. So whoever is not subscribed yet, kindly subscribe the channel so that you will get regular updates and share it to those who are preparing for KCET. And all the best for your exams. Thank you everyone.